ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. Welcome to the Learning Management Systems Department of Collegiate and Technical Education. So today I'll be starting with session 7 of Unit 2 Transistors and MOSFETs of Analog Electronics. So in this session I'm going to talk about two topics, that is transistor as a switch in CE mode, that is common emitter mode, and the various applications of transistor. As we have learned earlier, the two main applications of transistor is as a switch and as an amplifier. So in this session, we are concentrating on this particular application of transistor as a switch. And we have also learned that out of the three configurations of transistors, common emitter configuration is most widely used. Hence, we are discussing transistor as a switch in CE mode. So here is the picture of transistor connected in common emitter configuration to study how the transistor works as a switch. In the earlier sessions, you have already learnt about the three main operating regions of transistor. And what are those operating regions? One is cutoff region, saturation region, and active region. For the transistor to operate as an amplifier, it must be under active region. It must be operated in active region. And for the transistor to be operated as a switch, it has to be operated in cutoff and saturation region. So in this session, we are concentrating on cutoff and saturation regions. Under cutoff region, what will be the currents and voltages, and in the saturation, what will be the currents and voltages, we will discuss in this session. So this picture here, the transistor is connected in common emitter configuration as I said, and this circuit is similar to an open switch. Now let us consider the base emitter junction is applied with zero voltage, or it is sufficiently negative. If the base emitter voltage is sufficiently negative or zero, the base emitter junction is no more forward biased. Under this condition, there will be no emitter current, hence there will not be any collector current. Hence, the current flowing through, the collector current flowing through the load resistor RC is zero. Hence, voltage drop across RC is zero. In that case, all of the voltage VCC drop across the collector emitter terminal, that is VCE is equal to VCC. One important point to be noted here is we can take output either across the load resistor RC or across the collector emitter terminal VCE as VCE. So please remember, output can either be taken across the load resistor RC or across the collector emitter terminal. But output voltage taken across collector emitter terminal is most widely used, meaning that the output voltage is usually taken across the collector and emitter region. Even in this case also, output voltage means it is the voltage across the collector emitter terminal. So as I was explaining, since the collector current IC is zero, because emitter base junction is not biased, voltage drop across RC is zero. Hence, all of the voltages, it drops across the collector emitter terminal. Hence, VCE is equal to VCC. So this situation is similar to an open switch. As you can notice here, this condition, that is IC is equal to 0 and VCE is equal to VCC, this condition is similar to an open switch. So I have summarized those points here. When the base input voltage is enough negative, the transistor is said to be cut off and no current flows in the collector region, in the collector load. As a result, there is no voltage drop across RC and the output voltage ideally is equal to VCC. So under cutoff region, these are the main important points, that is IC is equal to 0 and VC is equal to VCC. This is equivalent, that is this condition is similar to that of an open switch, that is off state. Now look into the circuit which is similar to the closed switch. Now you can notice that the input section, it is connected to the VCC as well, thus providing sufficiently positive voltage to the base emitter terminal. In this case, the collector current flowing through the load resistor RC is maximum, that is saturation. So saturation current IC flows through RC, hence all of the voltage VCC drops across RC itself. So IC is maximum, that is IC saturation current, which is given by VCC by RC. So all of the voltage drop across RC, hence the voltage across the output terminal, that is collector emitter terminal, is equal to 0. So this is similar to closed switch condition. So closed switch condition states that IC is equal to maximum given by VCC by RC and VCE is equal to 0 volts. So this is similar to a closed switch. So almost short circuit between the collector and the emitter terminal. So the same thing has been given here. When the input base voltage is sufficiently positive, the transistor saturates, then IC maximum or saturation current will flow through RC. So under such conditions, the entire VCC will drop across the collector load RC and hence the output voltage will be equal to 0. Voltage is ideally 0 and IC is equal to maximum given by VCC by RC. So this condition is similar to that of a closed switch, that is on state. The same thing, that is switching action of a transistor, it can also be explained with the help of output characteristics. So here is the output characteristics for a common emitter transistor. It is drawn. So IC along the y-axis and VCE along the x-axis. And this is the AB is the DC load line. So you already know the concept of DC load line, how a DC load line is drawn. So we have to locate 2 points on the IC and VCE, and this point IC is the maximum IC, which is equal to VCC by RC. So you locate 1 point C on IC, and this is when IC is equal to 0. When there is no bias to the emitter base junction, IC current will be 0. In that situation, VCE is equal to VCC. So you have this point. When you join these 2 points with the help of a straight line, you will have this DC load line. So from this characteristics, we can locate all the 3 operating regions of the transistor. So the current where IB is equal to 0, the graph for the current IB is equal to 0, the line intersecting the DC load line, that point is the off point, that is cutoff point. Similarly, the graph for IB for maximum on the DC load line, that intersecting point what you get is the saturation point. So the area between these 2 points, that is cutoff point and the saturation point, is the active region. The same thing is redrawn here. The hatched area beyond the saturation point A is the saturation region when the transistor is fully on, and the hatched area below the curve IB is equal to 0 is the cutoff region. So both the cutoff and the saturation points are fixed points, and the area which is unstable between point A and B is the active region. So when the transistor is worked as a switch, then it has to operate either at saturation point or at cutoff point. When a transistor is operated as an amplifier, it has to operate within these 2 points A, B. It should not either enter saturation nor cutoff region. It has to be within this operating region for a transistor to be operated as an amplifier. So that's what we have here. When cutoff region, what it says, when the input base voltage is 0 or negative, the transistor is said to be in off condition. In this condition, IB current is 0, but still there will be some small amount of collector current due to the minority charge carriers, that is given by ICEO. O stands for opened emitter, because since we are not providing any voltage at the base emitter junction, it is treated as open circuited. So this is the collector current due to the minority charge carriers when there is no base voltage. Therefore, power loss can be given as output voltage into output current. So in the output condition, in the off condition, the output voltage is equal to VCC, since all of the voltage drops across the collector emitter terminal. And since ICEO is very negligible, I have already told you in one of my sessions, since the minority charge carrier current, the current due to minority charge carrier is very small, for most of the practical situations, that is neglected. Similarly, on or saturation region. So when a transistor is operated in saturation region, when the input voltage is made so much positive or high, the collector current maximum, that is saturation collector current, flows in the circuit. The transistor is said to be in the on condition. In this condition, the saturation collector current is given by Isat is equal to VCC minus VNE divided by RC. Since this voltage is very negligible, IC saturation is given by VCC by RC. Power loss, again output voltage into output current. So let's look into the active region operation. In this region, that is, active region is the region that lies between off and on conditions. Once again, let us look into the output characteristic. This is the point B shows the cutoff point and point A shows the saturation point. So the area between points A and B is the active region. So the off, between the off condition, it is the region that lies between off and on conditions. So the off and on regions are the stable regions of operation, whereas your active region is unstable. Hence, through which the transistor operation passes while changing from off state to the on state. Transistor switch off in the on ಹೋಗುವಾಗ ಅಥವಾ on in the off ಹೋಗುವಾಗ, it has to pass through the active region. So the path is being AB. So this is the path AB the transistor has to pass through while changing the state from off to on or on to off. So the collector current increases from ICEO to ISAT along the path AB as transistor is switched on. Similarly, when the transistor is switched off, the collector current decreases from ISAT to ICEO along AB. That is, when the transistor is switched on, the IC current, which is equal to ICEO right now, because IB is 0. Only the current due to the majority charge carriers is flowing, which is very less, and that is indicated as ICEO current. So when the transistor is switched on, the IC collector current, it increases from ICEO towards IC saturation. Similarly, when the transistor is switched off, so the collector current decreases from I saturation. The collector current decreases from this point, that is I saturation, maximum current, towards the minimum current, that is ICEO, that is the leakage current due to the minority charge carriers. So next, so till now we have understood all the three regions of operation of transistor, that is cutoff, saturation and active region. So we have also learned about the transistor operation as a switch. So when a transistor is operated, it has to be operated as a switch, it has to be operated either at cutoff region or saturation region. So when transistor is operated at cutoff region, it is said to be off. When it is operating in saturation region, it is said to be on. Now let's look into the various applications of transistor. So we already know the basic two applications of transistor, that is transistor as a switch and as an amplifier. But beyond that, transistors are also used in oscillator circuits, as voltage regulators and multivibrator. Multivibrators, they are nothing but signal generators, and also in many digital circuitry they are used. So at the end of the session, we have discussed about the transistor as a switch in common emitter mode, because common emitter mode is the most widely used configuration. So in CE mode, how the transistor is behaving or working as a switch, we have discussed and we have learnt also, and we have just gone through we have listed out some of the applications of the transistor apart from as a switch and as an amplifier. So let's look into few multi-choice questions related to the session. So the first question is, transistor amplifier always works in the dash region. So we all know the answer for this. When a transistor has to be operated in the as an amplifier, it has to work in which region? Let's look into the options. Active, cutoff, saturation, and the fourth option is cut-in. So we know the answer. The right answer is active region. It has to work in the active region in order to operate transistor as an amplifier. So the second question is, transistors are most popular for the application of. So ಯಾವ application ಗೆ transistor most popular? Let's look into the options. Option A is rectifier, B is amplifier, C as switch, D as filter. So which is the right answer? So there are two right answers for this question. So the transistor most popular application is both as an amplifier and as a switch as well. So answer option B and C, both are correct for this question. So the third question is, in which region a transistor acts as an open switch? So ಯಾವ region ನಲ್ಲಿ transistor open switch ಆಗಿ act ಮಾಡ್ತಾ ಇದೆ? So let's look into the options available. Option A is cutoff region, B is cut-in region, C is active region, and D is saturated region. So we know transistor operates as an open switch when it is operating in cutoff region. So option A is the right answer for this question. Let's continue with the next question. Fourth question, in which region a transistor acts as a closed switch? So answer ನಮಗೆ ಗೊತ್ತೇ ಇದೆ. Options ಏನೇನಿದೆ ನೋಡೋಣ. Option A is cutoff region, B is cut-in region, C is active region, and D is saturated region. So for the transistor to act as a closed switch, it has to be operated in saturated region. Yes, option D is the right answer. So that's all we have for today in this session. Thank you.